video, we are going over what I would dub as a super duper power objective, PO52, which is factoring, similar to 51, but again, like we've already talked about, it's got that coefficient to x squared. So not only do we have the b and the c term, we have to fit into our number puzzle, we also have to incorporate that a term as well, that coefficient to x squared. Okay? So this is a much longer process than it was with 51. I'm going to show every single step. It'll be verbalized, it'll be written down. Please be taking notes, follow along, ask your questions. I don't expect you to come away with it after the first one or even the second or the third one as factoring masters, but we'll give it our best shot and we'll go from there. So first things first, if we're able to, we want to make our numbers a little bit smaller. Okay, we want to factor out the greatest common factor of the three numbers in the trinomial. Okay, now we dabbled in GCF most recently in PO44. What's the greatest common factor of 12x squared, negative 38x, and 20? And you don't have to worry about the x at all because that constant doesn't have one, so x won't be part of the GCF. We're just looking at the numbers. What's the GCF between 12, negative 38, and 20? What can go into all three of them? 4. 4 does not go into 38, but does go into the other two. 2 does, okay? So we're going to factor out the 2. The GCF here is a 2, right? And when we say factor out, we mean divide by. So I'm going to put this a little bit lower so you can see what's going on here. So this 12x squared, if we're factoring out a 2, we're dividing 2 out of 12x squared. And what would that leave us with? 6x squared. Okay, so our a term is now going to be a 6x squared. We factor out a 2 of negative 38x. We're essentially dividing it by 2. What's our coefficient going to be now?
14.
Not 14. That'd be 28.
19.
19. And we have to make sure it's a negative 19, right? Because it's a negative 38x. And then we're going to divide 20 by 2 as well. And if we divide 20 by 2, we get 10. Very good. Okay? And that 2 that we took out is going to go in front of this new trinomial that we're putting in parentheses. Because to get back to our original one, we would distribute that 2 in, multiply 2 by 6 squared, will give us 12x squared. Multiply 2 by negative 19x, that gives us negative 38x. Multiply 2 by 10, that gives us the original 1. So when we factor this out, we're essentially undistributing, okay? And then we're going to get that 2 in as a coefficient to our parentheses. And then what goes inside of the parentheses, we're dividing each original term by 2. Okay? Now, step 2, multiply the a and the c term. What is the a term in this expression? Remembering that all of these parabolas, all of these trinomials are an ax squared plus bx plus c form. What is our a term? And we're kind of done with this for now. Now that we've factored out that 2, we're focused on what we have inside of the parentheses. What's the a term there?
6.
It is 6, okay? And we're multiplying that by our c term, which is 10, that constant, right? So a and c come from the a and the c term in our set of parentheses. A is 6, c is 10. And they multiply to give us 60. And that 60 is important because that's what we're using in our number puzzle. Number 3 is the familiar step. This is the number puzzle. But instead of just using the 10 here, like you did in PO51, because there's that a term, we have to incorporate that somehow. And how that's incorporated is multiplying it by that 10 to get the 60, so that when we set up our number puzzle, we're looking for 2 numbers that add to be the b term, just like before, but those same 2 numbers now multiply to equal 60, not the 10. Okay? So again, how I got this is the same number puzzle that we did in 51. The addition statement still comes from that middle term. That hasn't changed. But the multiplication statement, instead of just looking at that constant, now it's the constant times the a term, 6 times 10, and that's what we're looking at to multiply. And now it's just like PO51. Two factors of 60 that add to be negative 19. So let's start with the factors of 60. You've got 1 and 60. You've got 2 and 30. Stopping when we find the one that gets us to negative 19 there. 2 and 30. 3 and 20. 10 also goes into 60. 6 and 10. We're getting close. We can get a 17 out of 3 and 20, right? 20 minus 3. We can get a 16 out of 10 and 6. 10 plus 6, but not 19 yet. What else is there? There are two other factor pairs we haven't said yet. Yeah.
12 times 5.
12 and 5. I lied. There were 4 factor pairs, or 3 factor pairs. 5 and 12 also gives us 60, but we get 17 from 5 and 12, not 19, so we're not there yet. Anyone else know how to multiply to get 60? 15 and...
Wait. No.
You're right.
15 and 4.
15 and 4. And that's the winner, right? 15 and 4 is how we can get to 19. How? What signs do those numbers need to have here? Negative, both of them, right? Negative 4 and negative 15 add to be negative 19, because remember that plus negative means we're actually subtracting. So negative 4 minus 15 is negative 19, and negative 4 times negative 15 equals positive 60. So that's the winner. Okay? Now, step 4, again, because that A term is there, that original 12, now a 6, things are a little bit more complicated than the PO51. To set up our solutions, we're still looking for 2 sets of parentheses. We bring down our GCF of 2 that we had when we factored it out. But instead of just putting an x into both sets of parentheses, we're going to put in ax, meaning we're going to go back to that 6x squared, and we're going to put 6x, not the squared part, just the 6x, into both sets of parentheses. And the reason why we do that, actually, it magically helps us with the next part, which is putting these numbers in. Because somehow we have to get these x terms to multiply to give us 6x, okay? But we also have to put the numbers in the right spot, these numbers here from step 3, so that they multiply to make 60 and add to give us negative 19. So the idea behind this is if we start both sets of these parentheses the same, it's not going to matter which one gets the negative 4 and which one gets the negative 15, okay? If we start both sets of parentheses the same, it's not going to matter which set gets each of these numbers here. But if you think about it, if we FOIL crab claw box this, 6x times 6x doesn't give us 6x squared. So we've kind of cheated. And step 5 is where we fix it. Step 5 is say, okay, we put in an extra 6x. We now have to factor a 6 out. And we do that by simplifying. What can we divide both 6 and 4 by? 2. So I'm going to divide by 2 and divide by 2. And instead of 6x minus 4, that gives me 3x minus 2. And my second set of parentheses, 6x and 15, what can I divide that by? 3. So divide by 3, and instead of 6x minus 15, I get 2x minus 5. Yeah?
How'd you know how to divide by 2 and how to divide by 3?
I'm looking at the greatest common factor of 6 and 4, and the greatest common factor of 6 and 15. Okay? But here's the beauty of it, because math is awesome. We put in an extra 6x here. Notice what the two numbers that we divided by multiply to equal. 6. Okay? We kind of cheated by putting in an extra 6 here. We kind of cheated by putting in an extra 6 here to make our step 5 easier, or step 4 easier, as far as putting in that -4 and the -15. We fix that now by taking a 6 out, and we do that by simplifying both sets of parentheses. You can check yourself. This is kind of a checkpoint along the way. Mario levels, like that middle checkpoint where you can save your progress, so if you die later, you go back to it. It's the check flag, checkpoint city, okay? These numbers should multiply to equal the coefficient to your x term. Right? Step 6 is an extra step that I think 5 is enough, so we're not going to worry about that. This would be your final answer. Okay? If you want to foil crab claw box this, you can foil crab claw box your sets of parentheses. Johnny. If you want to FOIL crab claw box your sets of parentheses, you'll get this original 6x squared here. Watch. 3x times 2x is 6x squared. Here's -4x. Here's -15x. Here's +10. We know that -4 minus 15 combines to give us -19, which we have here, right? And then if we distribute our original 2 back in, redistribute, you're going to get the original expression that you started with. Okay? So you can check these by FOIL crab claw boxing your sets of parentheses. That will give you this expression right here after you factor out your greatest common factor. And then put that GCF back in, and you're going to get the grand original. Super duper, right? Okay. Hopefully you made it all the way to the end here. If you at least got to this step here, if you at least got to step 4, then you're in a good place right now. Because this is all kind of the setup stuff, the simplifying. Okay, that's easy to pick up once you kind of just get this part down. So if you can leave today understanding step 4. Things get a little bit hairy beyond that, but that's fixable, okay? 51, right? That's from yesterday, so I don't know. We'll see. Blake.
What are we going to use this?
Factoring?
Yeah.
This is your precursor to Algebra 2. This is your precursor to understanding what parabolas mean. When you're asked to analyze a parabola and find things such as the vertex, the axis of symmetry, things like that, the x-intercepts, this is the math that's required for that.
So, like, think of a scenario.
You enjoy your cell phone?
I don't have one.
Okay. You enjoy your DirecTV?
I don't have one.
Okay. Those that do, your cell phone towers, parabolas. Your satellite dishes, parabolas. All right? The technology that you enjoy and love here are because of parabolas.
How?
Okay. Well, you know what a cell phone tower looks like, maybe. Okay. But those receivers that are up there, right? They are curved, much like a parabola. And what it does, the receiver is here, right? Yep. So the signal comes in, and these have to be positioned just right, so that as the signal comes in, wherever it hits, it bounces off to hit that receiver.
So it's angles. Like if I throw a rock at a window, I have to like find an angle where that's directly hit or something like if this guy's on like a paddleboard hypothetically, and he's like stole my wallet or something. If I throw a rock and it like skips off the water, then it can hit this, let's say, canoe and put a hole in it. Because then I don't hurt him, but I also sink the boat and then get my wallet back.
Win-win.
Yep.
Okay. So, yes, Abby.
Will we ever use number 6, or is that?
Number 6 will depend on your teacher in high school. When I went to that math collaboration day, we talked about how high schools want answers when you're factoring something. And they said TG anyway, suggested they preferred leaving that GCF out. And since that's our largest feeder, then that's the way. Okay, no homework for tomorrow other than move on and get your practice work done.